All right, quickly, when looking at chemical bonding, we're actually looking at interaction between two or more elements to produce a compound. So a chemical bond is actually formed when two or more elements will do what? Interact. That is when they interact via their electrons. When two or more elements interact via their electrons, a chemical bond is formed. A chemical bond is formed in the process. Now there are different ways elements can interact with their electrons. Sometimes these elements can share their electron between each other and a particular type of bond is formed. Some other times there can be outright transfer of electrons. Another type of bond is formed. Sometimes there can be sharing of electrons, but only one of the electrons is bringing only one of the elements is bringing the electron for sharing. Another type of bond is formed. So class, today, the topic that gave rise to Lewis structure is actually chemical bonding. So we're going to be looking at chemical bonding, and then from there we'll take it to Lewis structure. From there we'll take it to resonance structure, and from there we'll take it to bond order and bond polarity, and then we'll take it to calculation of formal charge. If you ask calculate the formal charge or the bond order of a particular atomic species, we're going to be learning all that today. So, but first of all, we're starting with chemical bonding. So you're all welcome. So class, chemical bonding, we have three types of chemical bonding we'll be focusing our attention on. Electrovalence, covalent, also called molecular, and coordinate covalent bonding, also known as native bonding. So let's write down chemical bonding. This is the combination of atoms. Chemical bonding, this is the combination of atoms to form a molecule. This is the combination of atoms to form a molecule via a bond. This is the combination of atoms to form a molecule via a bond. Note, a molecule will only be formed if it is more stable and has lower energy than the individual atoms. A molecule will only be formed if it is more stable and has lower energy than the individual atoms. A molecule will only be formed if it is more stable and has what? Lower energy than the individual atoms. Class, why do we have chemical bonding? Chemical bonding occurs, alright, as we were saying, the main reason for chemical bonding is that all atoms want to achieve the octet rule. The number one reason why atoms bond is to attain the octet rule. The octet, class, this is what we call the octet rule. All atoms want to obtain an octet or duplet configuration. In the case of hydrogen, atoms want to obtain octet or duplet configuration. In case of hydrogen, hydrogen wants to obtain a duplet configuration. Other atoms want to obtain an octet configuration. So that's why elements are bonding. Class, we are well aware that if you look at atoms like sodium, sodium is number 11. It's not balanced, it's not stable. Sodium is 281. The electronic configuration of sodium is 281. Class, at this point, sodium doesn't have the octet configuration because the L shell, we have K shell, we have L shell, we have M shell. The M shell of sodium is not happy. The M shell of sodium is not what? Because the M shell of sodium requires 8 electrons to be balanced, to obey the octet rule. To obey the what? Octet rule. The M shell of sodium requires 8 electrons to obey the octet rule. But class, currently it has just 1 electron, so it's not stable. So this will push sodium to go and bond with another element. This will push sodium to go and bond with another what? Look at someone like chlorine, 287. The K shell is happy, the L shell is happy, but the M shell is not. The M shell requires 8 electrons to be completely what? Satisfied. So this will push chlorine to go and bond. Class, this is the reason for bonding. The main reason for bonding is the elements looking for ways to complete their what? Their shells with the required number of electrons. Elements or the atoms are looking for ways to complete their shells with the required number of what? Atoms, electrons. So write down. Atoms always seek to attain a stable electronic configuration, just like the noble gases. Atoms always seek to attain a stable electronic configuration, just like the noble gases. Atoms always seek to attain a stable electronic configuration, just like the noble gases. Atoms always seek to do what? Attain a stable electronic configuration, just like the noble gases. Atoms can achieve stable electronic configuration in a number of ways. Atoms can achieve a stable electronic configuration in a number of ways. Atoms can achieve a stable electronic configuration in a number of ways. One, by losing electrons. One, by losing what? Electrons. Two, by gaining electrons. One, by losing electrons. Two, by gaining electrons. Three, by sharing electrons. Class, atoms can achieve stability in a number of ways. One, by losing electrons. Two, by gaining electrons. Three, by sharing electrons. So these are the ways in which atoms can achieve stability. One, by losing electrons. Two, by gaining electrons. Three, by sharing electrons. By gaining electrons, by losing electrons, by sharing electrons. Now write down the octet rule. Write down octet rule. The octet rule states that atoms get involved in the formation of chemical bonds. The octet rule states that atoms get involved in the formation of chemical bonds. The octet rule states that atoms get involved in the formation of chemical bonds through the gain, loss, or sharing of electrons of the outermost shell. Atoms get involved, states that atoms get involved in the formation of what? Chemical bonds through the what? Gain, loss, or sharing of electrons of the outermost shell. Through the gain, loss, or sharing of electrons of the outermost shell. So that they can obtain an octet outer electron configuration. So that they can obtain an octet. We have three major types of chemical bonds. We have three major types of chemical bonds. One, we have the electrovalent, also known as the ionic bond. Electrovalent or ionic bond. One, electrovalent or ionic bond. Two, covalent or molecular bond. Two, covalent or molecular bond. Three, coordinate covalent or dative bond. Three, coordinate covalent or dative bond. There are three major types of bond. We also have minor bond. Hydrogen bond is a minor bond. We have Van der Waals bond is the weakest bond. Then we have metallic bonding. But we have three major types of bond. Electrovalent, also called ionic bond. Covalent or molecular bond. Coordinate covalent, also known as dative bond. Class, let's now start electrovalent or ionic bond. Let us start with electrovalent or what? Ionic bond. This is a bond that involves the complete transfer. Electrovalent or ionic bond. This is a bond that involves the complete transfer. This is a bond that involves the complete transfer of one or more electrons from the outermost shell of one atom. I'll come again. This is a bond that involves the complete transfer. This is a bond that involves the complete transfer. This is a bond that involves the complete transfer of one or more electrons from the outermost shell of one atom. This is a bond that involves the complete transfer of one or more electrons from the outermost shell of one atom to the valence shell of another atom. To the valence shell of another atom. This is a bond that involves the complete transfer of one or more electrons from the outermost shell of one atom to the valence shell of another atom. To the valence shell of another atom. To the valence. Valence. V-A-L-A-N-C-E. To the valence shell of another atom. Note, the atom that loses electron will become positively charged. The atom that loses electron will become positively charged, while the atom that gains electron will become negatively charged. The atom that loses electron will become positively charged, while the atom that gains electron will become negatively charged. The atom that loses electron will become positively charged, while the atom that gains electron will become negatively charged. The atom that loses electron will become positively charged, while the atom that gains electron will become negatively charged. So, class, in other words, during electrovalent bonding, two types of elements are formed. We have the electropositive element and electronegative element. The electropositive element is the element that loses electron, right, to become positive, right? And the electronegative element is the element that gains electron to become negatively charged. Class, this type of bond is usually seen between a metal and a non-metal. Between a metal and a what? Electrovalent bond is usually seen between a metal and a usually seen between a metal and a non-metal. Electrovalent bond usually seen between a metal and a non-metal. Class, in electrovalent bonding, there is complete transfer of electrons. Class, sodium is a metal, chlorine is a It's a simple math, class. Sodium needs this one electron to go because this M shell is not happy with this one electron. The M shell prefers to lose the one electron and not have anything than to have one. Because the M shell is only happy when you have 8 electrons. So this one electron is not doing anything here. But class, the M shell of chlorine just needs one more electron and it's going to be happy. So there's total transfer of one electron from sodium to what? Chlorine. But sodium loses one electron and becomes positive, right? Plus. Chlorine gains this one electron and becomes negative. So there's formation of electropositive and electronegative species during ionic bonding. And NaCl is formed. So what's joining Na and Cl together is ionic or electrovalent bonding. Ionic or electrovalent. So let's go to covalent bond. Let's go to covalent bond. I said another name for covalent bond is molecular. In case you asked in the exam, another name for covalent bond is also known as molecular bonding. Let's look at covalent bond, class. Covalent bond, class, let's go. This is a type of chemical bonding where the two atoms forming the bond shares electrons in the outermost shell. This is a type of bonding with the two atoms sharing forming the bond. This is a type of bonding in which the two atoms forming the bond. This is a type of bonding in which the two atoms forming the bond share electrons in the outermost shell to attain a stable noble configuration. To attain a stable noble configuration. I'll come again. This is a type of bonding where the two atoms forming the bond. This is a type of bonding where the two atoms forming the bond share electrons in the outermost shell. In the outermost shell to attain a stable noble configuration. To attain a stable noble configuration. Class. What is a stable noble configuration? It depends on the element. For someone like sodium, sodium wants to attain 8 in the outermost shell. Any element that ends with 8 in the outermost shell has an octet. Octet means 8. Octet means what? But for someone like hydrogen, hydrogen doesn't want to attain an octet configuration. It wants to attain a duplet. Because hydrogen has 1 electron. And the K shell of hydrogen needs just 1 more electron to be stable. Because K shell does not need 8, it needs 2. So for someone like hydrogen, it needs a duplet configure. Duplex means 2. Duplex means. So class, depending on the element, will determine what kind of configuration the element needs. So class, what happens in covalent bonding, also known as molecular bonding? A good example is between the 2 molecules of hydrogen or even the 2 molecules of oxygen. The 2 atoms of oxygen, sorry. The 2 atoms of oxygen to form the molecule of oxygen is covalent bonding. The 2 atoms of hydrogen to form the molecule of hydrogen is covalent. In covalent bonding, the sharing of electrons class. Look at hydrogen. If we have 2 hydrogen atoms, these are 2 hydrogen. This 1 hydrogen is another hydro. Class, with 1 more electron here, this hydrogen is stable. With 1 more electron, this hydrogen is what? So 2 of them will come together, so let us share. 2 of them will come together, so let us what? This guy will bring his own electron. This guy also brings his own. And they share. And they do what? And by sharing it, class, it now means that these 2 electrons belong to both of them. And both of them are now stable. It means that this guy has 2 electrons, this guy also has 2. Because I brought 1, you brought 1, and we now have 2. What I need to be stable is 2. What you need to be stable is 2. You have 1, I have 1. Let's bring our 1, 1 together, and we both have 2. Anytime you need your 2, you have it. Anytime you need my 2, I have. Let us share together. Let us share. Just like the roommates. Our strength is maybe 250. You have 125. You are not stable in the house. The other person has 125. She's not also. So bring your 125, I bring my 125, and we share. So nobody entirely has the house, but we both have stability in the house now, right? That's what's happening here. Nobody entirely has the electron, but we both have what? Stability. Okay, we are both stable now. Same thing happens between the molecule of oxygen class. Oxygen is 2, 6. Electronic configuration of oxygen is 2. So look at oxygen. Because if you are naming your elements, oxygen is number 8. This 2 and this 6. Another oxygen again, 2 and 6. Class, this guy needs 2 more to be stable. This guy also needs 2 more to be. So this guy will bring 2 out. Also bring your 2 out. And they do what? They share. So let these 2 and these 2 come out. And then there's bonding. There's what? So that if you now count, if you want to count number of electrons on this share, say 1, 2, 3, 4, 5, 6, 7 is happy. You want to count number of electrons here, 1, 2, 3, 4, 5, 6, 7. So at no point is this electron belonging to any of them. They now share. And both of them now form the oxygen molecule. Class, it's important to note that the covalent or molecular bonding is peculiar between 2 non-metals. Unlike the electrovalent bonding, where we said it between a metal and a non. But the covalent or molecular bonding for covalent bond is molecular. It's usually between 2 non-metals and they share their electrons. Each person brings equal number of electrons for sharing class. In covalent or molecular bonding, each of the atoms bring equal number of electrons for sharing. It's important that you know that word equal, because when we get to coordinate covalent, 2 of them don't bring equal number of electrons for sharing. In fact, only 1 person is bringing an electron that 2 of them are sharing. In coordinate covalent, but in normal covalent bond, 2 of them bring equal number of electrons for sharing. Class, we're given the definition of covalent, right? Did we? Yeah. And between 2 non-metals. So this, I'm giving you an example. Let's go to coordinate covalent. Coordinate covalent bonding now. Class, just that I remembered now, you know that we have two types of electrons actually. You know we have two types of electrons for each atom. We have what we call the inner core electrons. Inner what? And we have the valence electron. The valence what? These valence electrons are the electrons on the outermost shell of the atom of the elements. Come on. The electron on the last shell. Electrons on the what? Class. So someone gives you an element and say determine the number of what valence electron. Or determine the number of inner core. Class. Look at sodium. Na. 28. This K shell, this L shell, this M. These first two are the inner shells. So this guy has 10 inner core electrons. 10 what? And 1 valence. Please take note. It's something as simple as this. You might not know this is what they're asking you. How many inner core electrons are found in sodium? How many valence electrons are found in sodium? It has 10 core electrons and 1 valence. Class, it's important to know that during bonding, only the valence electrons are involved in bonding. Only the valence electrons are involved in what? Whether it's ionic bond, whether it's covalent bond, whether it's coordinate covalent, only the valence electrons are involved in bonding. I just thought to say that. Let's now go to coordinate covalent bond. Coordinate covalent. As the class is quiet now, it's favoring everybody. Both you that is learning, those that came to read, they are gaining from making the class quiet, right? So people came here to this exam period. As I've made the class quiet, I favored them now. They are reading well. Nobody's stopping. Someone that came to rest his head in the class, you didn't come to, you just came to rest your head. I've also helped you now, you can sleep well, rest your head. When everybody's making noise in the class, nobody wins, everybody will lose. Class, coordinate covalent bond is a type of covalent bond, right? There's a type of covalent bond in which the electrons for sharing by the two atoms is a type of covalent bond in which the electrons for sharing by the two atoms is a type of covalent bond in which the electrons for sharing by the two atoms is donated by just one of the atoms. It's a type of covalent bonding in which the electrons for sharing by the two atoms is donated by just what? One of the atoms. Is donated by just one of the what? Only one person is bringing class. Only one person is what? You and your roommates are in the room. You want to make food together. Only one person is buying things. And one person is eating. One person is what? When I was in school then, I had one roommate like that. I said, come, let's cook now. You know, you say, I'm fasting. So you have not cooked everything. So, okay, so you know the chop a bit. Pray for us, so I beg. You now go to market, buy soup, buy all the obstacles inside the soup, you understand? And then you have done it's when my food has done that you want to break your fast now. You are fasting since. As soon as my food is, you started praying. I said, guy, why you did pray now? You know the fast again. He said, I want to end my fast. Food already. I said, how? Are we together? Are we together? So, one person is bringing, one person is just waiting for food to... I also had one friend like that. It's when my food is ready, as soon as anytime you cook, I don't know how he knows when your food is done. That's when he will knock on your door. We used to call him food alarm. Food. The guy knows anytime, if he's your friend, anytime you just finish cooking, that's when he will visit you exactly when you finish. He will not knock when you have cooked so that you can hide and not serve him. When you have served the food in the plate, you have brought it to your... You will now do what? And when he knocks, he like, don't have spoon. Say, my spoon don't finish, no best. About somebody you can't chop. My spoon don't. I no get spoon. Sorry, I say, you know what I have? He always goes around with one as a first aid box. First aid class. Examples of coordinate covalent bond. We have NH4+, and we have H3O+. NH4 plus and H3O plus. Class, let us show you what happens in NH4 plus. Class, the extra hydrogen in this NH4, class, NH4 is actually made up of NH3 and an hydrogen ion, H plus. Class, H plus means that how many electrons are contained in an atom of hydrogen? One electron, one. H plus one, that means that when you have plus, what does it mean in chemistry? You have lost. It means that H plus means that you have no single electron. That one electron that hydrogen usually has even lost it. He has what? Are we together? Now class, look at NH3. N is, the bonding between nitrogen and hydrogen is covalent. Is what? The bonding between nitrogen and hydrogen is covalent. Class, without it H plus, this NH3 is existing normally. Because watch, N is number 7, which is 2, 5. 2 what? So 2 on the K shell, 5. Five on the L. Class, nitrogen needs how many electrons to obtain octets? 3. It is what? It will go and gather 3 different hydrogen atoms. All these hydrogen atoms need one more electron to be stable, right? So class, this hydrogen will bring one of his electrons and come and join here. So let us share together. I need one, you need one. This second hydrogen will come here, let's share. I need one, you need. The third hydrogen will come here, let's share. I need one, you need. So each of the hydrogen are now stable because the hydrogen needs 2 to be stable, right? 2 is stable, 2 is stable, 2 is. And nitrogen also has its own complete 8. 2, 2, 2, 2. 2 times 4 is now stable. Everybody's happy. Everybody's what? This NH3, this NH. Class, this NH3 does not need any other person to come and bond with him. But class, this empty H plus that has nothing. How many electrons does it need to be stable? 2, right? You will see that there's still 2 electrons. Let me adjourn you. Let me just follow you now. Without bringing any. Just like, have you ever seen when 2 people have already rented house, furnished everywhere? And there's a third person that just staying there. This guy. They are furnished everywhere. There's foodstuffs. And you know that you that cook your food and the person that did not cook the food, who used to eat the food the most? You just cook soup, put meat, put everything. When you are serving it with the blood of Jesus. Small. In fact, the meat self, you collected, you return it back, say, no man, no chop meat today. Let me just take one. You're not collecting, you're not cutting into 2. You're managing your soup small. You're not left, your roommate now came back and saw soup. His hand just shy. Carry big spoon. Back like 4. This true life story about the roommate like that. Me that's cooking, I don't carry half. I said, okay, when my meat, and I say, I just use and break my fast. I go pray for you. Back like what? 4 meats. So the energy comes in here and takes the 2 electrons. It did not bring anything into this compound, but it's taking 2. And NH3 now becomes NH4. This happens here. Also happens in H3O plus. Plus, H3O plus contains H2O and H. H2O is happy already, class. H2O means oxygen. Oxygen is 2,6. 2 what? Oxygen needs 2 more electrons to attain octets because it's 2,6. So you go and collect hydrogen. One hydrogen will come here with 1 electron and give him. Another hydrogen will come here with 1 electron and give. And now everybody's happy. But this extra hydrogen that is empty will come and take this other 2. Coordinate covalent bond. Class, you can be given a compound and asked to list all the bonds that are found in the compound. Class, popular question that usually come out is NH4Cl. How many bonds? List all the bonds in NH4Cl. Class, the 3 major types of bonds that we have in chemistry are all here, class. Of course, I've shown you NH3, right? Covalent. The bond between hydrogen and hydrogen from NH3, covalent. Now, when the extra hydrogen came in, coordinate to form NH4 plus, coordinate what? An NH4 plus reacting with Cl minus. Anytime an electron positive element, a negative element react, ionic or electro. These are the 3 bonds in NH4Cl. NH4 covalent, coordinate covalent, and electro. Write down bond polarity. Bond. Write down bond polarity. Write down bond polarity. Bond polarity. Write down bond polarity. Note, for a covalent bond, where the two atoms forming the covalent bond are identical. For a covalent bond, where the two atoms forming the covalent bond are what? Identical. For a covalent bond, where the two atoms forming the covalent bond are what? Identical. That is having same electronegativity. That is having same electronegativity. I say note, for a covalent bond, where the two atoms forming the covalent bond are what? Identical. That is having same electronegativity. That is having same what? Electronegativity. The covalent bond is said to be non-polar. The covalent bond is said to be non-polar. The covalent bond is said to be what? Class, have you gone through your past system before and you see 3 or 4 and say which of them is more polar? Which covalent bond is more? And you'll be wondering how will I know which one is more polar now? I want to teach you how to determine bond polarity. Arrange the following compound in order of increased polarity. Who has the highest polarity? I will teach you. I say note, for a covalent bond where the two atoms forming the covalent bond are identical, right? That is having the same electronegativity. The covalent bond is said to be non-polar. Class, look at this. Between hydrogen and hydrogen, when they have hydrogen and hydrogen have the same electron, they are the same atom. Chlorine and chlorine, they are the same. These guys are said to be non. In fact, class, anytime you have to arrange a group of bonds in order of increasing or decreasing polarity, class, the people with the weakest polarity are those people that are the same. Chlorine bond, hydrogen, hydrogen, but they are the ones with the slowest polarity because the electronegativity between two of them is exactly the same. So there's almost no polarity existing between them. Zero polarity. Then you now followed by when the atoms are different, at least. Class, these guys are more polar, even if they are still non-polar. Class, generally, anytime you have a bond between two non-metals, they are generally non-polar. They are generally what? Class, polarity increases if there's a big difference between the two atoms forming the bond. Maybe one is a metal, one is a one is electropositive, another one is electronegative. They are more polar. Because class, polarity means the distance between two opposite ends of an atom. The farther apart they are in terms of charge, the more polar the bond. So class, someone that is negative, chlorine is negative, sulfur is negative. This guy will be less polar compared to someone that is Na positive and chlorine negative. There's a big difference between plus and minus compared to minus and. So there's more polarity here than. So if you're talking about increased polarity, class, the compounds with the lowest polarity are those of similar, followed by those of different atoms, but they are still non-metal. They are still what? Then you now come to those with what? Like that, a metal and a non. The bond between a metal and a non-metal has the highest polarity, class. Has the what? Notes, write down. The greater the difference in electronegativity, between the two atoms, the more polar their bond. The greater the difference in electronegativity between the two atoms, the more polar their bonds. The greater the difference in electronegativity between the two atoms, the more polar their bonds. Class, have you seen a question like this before? You must have been studying your past question. Which is more polar between BCl, B means boron, B means what? And CCl, C means carbon. Class, between BCl and CCl, class, I won't give you two reasons. I'll give you two. Number one, first of all, boron is a metal, carbon is a non-metal. Class, they are both bonding to the same person. Between metal and non-metal, and between non-metal and non-metal, which is more polar? If you have been listening to me, who is more polar, class? Thank you. The polarity increases between a metal and a non-metal compared to metal and compared to non-metal and non-metal. What if they put BCl, CCl, and ClCl? Well, between CCl and ClCl, who is more polar? CCl is still more polar than ClCl, right? Look at these ones, they are different. So there's a difference in electronegativity, class, right? Compared to these ones that are the same, having the same electronegativity. So as I've told you, it means you are following. It means the atoms with the similar electronegativity are the least polar bond. Class, another reason why this guy is more polar than this guy is that between boron and carbon, there's a wider difference in electronegativity, class. Class, let's look at our periodic table. You see that the boron family is here. If you look at the periodic table, you have hydrogen, helium on this side, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So class, if you come here, you see sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Class, look at B and look at C. The distance between B to Cl and C to Cl. B is farther away from Cl than C. So therefore the polarity is more. The polarity is what? Compared to C to Cl. Are you seeing the short distance? So there's more polarity. The distance between two atoms also determines the polarity. That's why when you see Na and Cl, are you seeing how far they are? Na and what? So if someone asks you between Na and Cl and between Al and Cl, who is more polar? NaCl is more polar than Al, but there's a distance in the electronegativity between two of them. Class, which is more polar, PF or PCl? PF or PCl? Why do you choose PF? Class, you are correct. P is in the same period with Cl, I've seen it here, but it's further away from PF. So PF definitely is more polar than PCl. Another question. Okay, you get this one. You will get this one. Which is more polar, BCl, CCl, FF, HF, AB. Class, it's not AB, therefore you don't even know which AB. So which is more polar? BCl, CCl, FF, HF. Where's the other one? HF, yes. AB is not part. Which is more polar? HF, you are correct. HF is more, because distance in the electricity between H and F compared to B and Cl. Compared to what? There's more distance between H and F compared to B and what? Cl. Good. Now class, write down Lewis dot structure. Lewis dot structure. Class. Just by the way, I just saw this question. Which of the following pair of atoms gives ionic bonds? Which of the following pair of atoms gives ionic N and O, B, S and F, C, C and O, D, N, A and O? Which of these will give an ionic bond? What's the name for ionic bond? Electrovalent? D, right? Because this is metal and a non. The rest is between non-metal and non-metal. Non-metal, 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 non. But this is the only one that has a metal and a non. An ionic bond is formed between a metal and a non-metal. Good. Lewis structures are diagrams that show the bonding. Write down. Lewis structures are diagrams that show the bonding between atoms of a molecule. Lewis structures are diagrams that show the bonding between atoms of a molecule and the lone pairs of electrons that may exist in the molecule. And the lone pairs of electrons that may exist in the molecule. Lewis structures are diagrams that show the bonding between atoms of a molecule. Lewis structures are diagrams that show the bonding between atoms of a molecule and the lone pairs of electrons that may exist in the molecule. Lewis structures are diagrams that show the bonding. Lewis structures are diagrams that show the bonding between atoms of a molecule and the lone pairs of electrons. Between atoms of a molecule and the lone pairs of electrons that exist between the molecule, that exist in the molecule, that exist in the steps in drawing Lewis structure. Steps in drawing Lewis structure. Steps in doing what? 1. Determine the total number of valence electrons. 1. Determine total number of valence electrons. 1. Determine total number of valence electrons. Determine total number of what? Are you there? 2. Determine the central atom. 2. Determine the central atom. 2. What? Determine the central atom. Note, the central atom is usually the least occurring element or the least electronegative element in the spaceship. Note, the central atom is usually the least occurring element or the least electronegative element in the spaceship. The central atom is usually the least occurring element or the least electronegative element. The central atom is usually the least occurring element or the least electronegative element in the what? Spaceship. Three. Are you there? 3. Use bonds. Use bonds to link the central atom to the other atoms present in the spaceship. Use bonds to link the central atom to the other atoms present in the spaceship. Use bonds to link the central atom to the other atoms present in the Specie. Recalling, continue writing, recalling that each bond represents 2 electrons. Recalling that each bond represents 2. Recalling that each bond represents what? 2 electrons. Recalling that each bond represents 2 electrons. Recalling that each bond represents 2 electrons. Now, continue writing. Now, subtract total number of electrons used via the bonds. Subtract the number of electrons, you don't use total yet. Subtract the number of electrons used up via the bonds. Subtract the number of electrons used up via the bonds from the total number of valence electrons. Subtract the number of electrons used up via the bonds from the total number of valence electrons. Subtract the number of electrons used up via the bonds from the total number of valence electrons. Subtract the number of electrons used up via the what? Bonds from the total number of valence electrons. Are you there? Now, next step. Use the remaining number of valence electrons. Use the remaining number of valence electrons to complete the Lewis structure, ensuring the valence octet rule is obeyed. Use the remaining number of valence electrons to complete the Lewis structure, ensuring the what? Octet rule is obeyed. Use the remaining number of valence electrons to complete the what? Lewis structure, ensuring the what? Octet rule is obeyed. Ensuring the what? Octet rule is obeyed. Class, let's look up. Everything I'm saying will not make sense to you until we apply. Assume we have to draw the Lewis structure of H2. Class, first things first. Determine the total number of valence. Class, you list all the atoms present in H2. There are 2 hydrogen atoms and there's 1 oxygen. Thank God I've taught 2 types of electrons. There's one between valence electron and inner core. We don't use the inner core electrons to draw Lewis structure. We use only the valence. How many valence electrons does 1 hydrogen atom have? 1, right? But there are 2 hydrogens in it too. So number of electrons there are 2. Valence electrons are what? For each of the hydrogen contributes 1 valence electron, right? How many valence electrons does oxygen have? 6. Because electronic configuration for oxygen is 2, 6, not 2, 8, 2, 6. 2. Oxygen is number 8. Remember, if you're writing the configuration, it will be 2 on the K shell, 6 on the L. So 6 valence. Therefore, total number of valence electrons in H2 is 2 from hydrogen, the 2 hydrogens, and 6 from oxygen, meaning what? 8 valence. Total number of valence electrons is 8. We have obeyed step 1. That asks us to determine total number of valence. Step 2 asks us to determine the central. Class, the central atom is the least occurring atom. Class, we have 2 hydrogens and we have 1 oxygen. Who is the least occurring? Oxygen is occurring once, hydrogen is occurring. For class, even if hydrogen is occurring once, never use hydrogen as your central atom. Class, madam, we are having class and you are selling pure water and even recording the class. This is what I was shouting about. Is this right, class? Be honest. It's wrong. I should just came to stand in front of the stuff we are recording. Is this wrong? Is this right?
I didn't even say sorry.
Because when I'm shouting, look at me, I'm just shouting. This is just like shouting. Someone just came and carry pure water in a class that is holding with the full air country. Carry the pure water and pass in front of the camera, what we are recording in the class, and stood in front. Is it right? How many pure water she sold now? Some things that are wrong that we just take as normal in Nigeria, they're actually wrong. In a class where class someone is okay, buy your pure water, someone won't bring meat, buy your meat inside the class. It's wrong. Nobody say I'm spoiling anybody's business. You can sell it outside. People will still come and buy. They short. Go and sell your pure water, sell your things. I don't have any problem with that. But in a class where class is going on, someone hawking pure water, people will be pressing their phone. You'll be shouting inside the class. It's wrong. Let's tell ourselves it's wrong. That's like someone like shouting. It's wrong, actually. What is wrong is wrong. Class. We have determined our central atom. Use bonds to link the central atom to the other atoms. Who are the other atoms? Hydrogen. Now, recalling that each bond takes up what? Anytime you use a bond, class, you are using two electrons. 2 plus 2. It means you have used up 4 electrons out of total number of valence electrons 8. But class, is this total number of valence electrons you use to draw your Lewis structure? It is this total number of valence electrons that you use to draw your Lewis structure. Just watch. Class, 2 plus 2. 8 minus 4. Why are we subtracting 4? Because by using 2 bonds, we have used up 4 electrons. Each bond represents 2. Only 4 electrons are remaining, class. The next step says use the remaining 4 electrons to complete the Lewis. Class, let me tell you something. The Lewis structure, hydrogen needs 2 electrons to be stable in your Lewis structure. So class, anytime there is a bond with hydrogen, hydrogen is already stable. Anytime there is a bond with hydrogen, hydrogen is already what? The person that needs to be stable now is this oxygen. Class, we take these remaining 4 electrons and turn them to dots. That's why it's called Lewis dot structure. Class, the remaining 4 electrons, why are we adding 4 electrons here? Let me tell you something, class. Oxygen needs 8 electrons to be stable. Only hydrogen needs 2 electrons to be stable. Only hydrogen needs what? Only hydrogen needs 2 electrons to be stable. Most other elements need 8 to be. So class, this oxygen has how many electrons? Before I put this 4, it has 4. This bond is giving it 2 electrons. This bond is giving it 2 plus 2. To make 8, how many more does it need? So to take this 4 here, 0. Collect the 4 electrons and turn them to what? This is how you show electrons on an atom. And the Lewis structure is complete. Let me come again. Class, the essence when you are drawing your Lewis structure, every atom in your Lewis structure must have either duplet, like hydrogen must have 2 electrons. Every other atom must have 8. So the first step is determine total number of valence. We all know how we got the valence electron, class. Is that correct? We all remember how we got the valence electron? Hydrogen is bringing 1 electron, but you have 2 hydrogens, that's 2. Oxygen is bringing 6 valence electrons. We're not using these 2, we're using only 6. Valence electron is the outermost electron. So oxygen brings 6 valence electron, hydrogen brings 2 valence, 2 plus 6, 8. We have obeyed the first step, determine total number of valence. Step 2 says determine the central. How will you know which central atom? The least occurring. Hydrogen can never be your central atom. Class, when drawing Lewis structure, you will never see hydrogen in the center. Class, who you pick as your central atom will determine whether your answer is correct or wrong. If you pick the wrong central atom, you're already on the wrong path. Class, oxygen is the central atom because number 1 is the least occurring. Hydrogen is occurring twice, oxygen is occurring. So who will you pick? The least occurring atom. But I just told you now, even if hydrogen is occurring least, never pick hydrogen as a central. Why? Because the central atom will eventually be bonded to other atoms. And by the time you put hydrogen in the center, class, and you start bonding with other atoms, class, you overwhelm hydrogen. Because each bond you are giving to that hydrogen is give 2 electrons, 2 plus 2, 4 plus 2. Class, 6, half hydrogen has 6 electrons. How many electrons does hydrogen need to be stable? Just 2. So you can say hydrogen never fits to be in the central atom. Because it doesn't have the capacity to take more than 2. It doesn't have the capacity to take more than 2 what? So hydrogen can never be your central atom. So oxygen is central atom. Now class, how can you go to your central atom? Use bonds to link your central atom to the other. How many other atoms do you have? You have 2 hydrogens, right? So I link bond the hydrogen and the other hydrogen to this. Anytime you use a bond in your Lewis structure, you have used up 2 electrons. You must subtract the number of electrons you have used from total number of valence electrons available. How many electrons do we have available? 8. By introducing 2 bonds here, how many electrons have you used? 4. 8 minus 4. Only 4 electrons are remaining. And when you're done with your Lewis structure, all the electrons must be finished. And all the atoms in the Lewis structure must have either 2 or 8 electrons around them. Every atom must have either 2 or what? Why did I say 2? In case of hydro, and 8 in case of other. Class, as it stands now, by giving one bond to hydrogen, hydrogen is okay, right? In your Lewis structure, you will never see a dot around hydrogen, because by giving a bond to hydrogen, hydrogen is okay. One bond means what? And this bond also means what? So these 2 hydrogens are happy. 2 electrons is okay to make hydrogen. Who is not happy now is oxygen. Well, as it stands now, class, before I put this dot, you must ask yourself, how many electrons are around oxygen now? 4. This bond is giving him 2. This bond is giving him 2 plus 2. And I said before you finish, say you have finished drawing your Lewis structure, every atom must have 2 or 8. All atoms in your Lewis structure must obey the octet rule. Octet means 8. Or duplet, 2, which is hydrogen. Currently it has 4. You must transfer the remaining 4 electrons that was there. How do you represent electron in Lewis structure? Use dot. Use what? How do you represent electron in Lewis structure? Use. So this oxygen, we know that this oxygen needs 4 more electrons to obtain the octet 8, right? 1, 2, 3, 4 minus 4. Class, a good Lewis structure is when you have used up your complete valence electron and every atom in your Lewis structure is stable. Every atom in your Lewis structure is what? Stable. It's happy. Let's say happy, yes. Class, is that okay? I'm sure you know that me putting a 2 should tell you that this is the simplest Lewis structure I ever asked you to draw, right? You know that this is the simplest Lewis structure they can ever ask you to. But I needed you to start with something simple so you can understand first. Class, Lewis structure is a short topic in Chem 130 exam. It's short. Check every year of your past question. Draw the Lewis structure. If they don't say Lewis structure, they'll say draw the resonance structure. It's short. I know the funny thing. Someone will ask me, they ask us to draw Lewis structure in the exam. Are we to show all these steps? Total number of valence electron? No, class. Just write, draw it. Get the answer. Get the final. Don't show how you got it. Just get the final. Don't start writing valence electron, class. Just draw the Lewis structure. Lecturer will know if you are correct or. Let's go to tougher ones now. Now that you have the foundation, let's go to tougher. Draw the Lewis structure of H2SO4. H2 what? Follow me. Please, I hope it's still recording. Draw the Lewis structure of what? H2SO. Class, what's the first step? Determine total number of valence. First step is to determine total number of valence electrons. H2 means we have 2 hydrogens, S, 1 or sulfur, and 4 oxygens. 4 what? O4 means 4. How many valence electrons will 2 hydrogen give us? 2. Sulfur is 6 valence electrons because sulfur is number 16 on the element table. Sulfur is number 16 on the element table, but we don't need all the 16 electrons. We need just the outermost, which is 2, 8, 6. This last electron is what we need for sulfur, 6. Remember, we only use valence electron to draw Lewis structure. We only use what? We only use valence electron to draw Lewis. So sulfur is 2, 8, 6. The last electron, 6, is what we use. Oxygen is 6 valence electron, but we have 4 of them. 4 times 6. So we now add it up together. 2 plus 6. 8 plus 24. But total number of valence electron is 30. Total number of valence electron is 32. Don't forget, always is only the valence electron. Don't forget that if anything I teach in this class, I was too fast. There's a video for you. Like the shortcut class did on Saturday. If you've forgotten any shortcut I taught, go back to the video and watch it. I even sent a PDF, right? Shortcut PDF on the group. Today they gave test Math 110. They did department. I did almost all departments. So that I don't think any of our students should have any complaint, because I think I told you guys that we will give you more value than what you. So definitely, I don't think you should have any feeling of more value than what you paid for. Definitely, with the way we are teaching and the way we are recording the class, step by step. Now, so if you have any issue with this thing, you can go and watch it again. I will upload it. I will do what? I'm going to watch this slowly again. Are we together? I plan on uploading some of you join the group late, the paid members group. I will upload all videos that we have done so far. And then yesterday I uploaded all the physics labs we have done so far. Class, who is the central atom? It's clearly solved for the least occurring atom. Please, get that man that should not come in. Please, fast, please, be fast. Please tell them that they should not come in. Tell them that they should not come. Close the door quickly. Close the door, please, close the door. Sulfur is the central atom. Now use bonds to join the central atoms to the other atom. Use bonds to join the central atoms to the other what? Atoms. Class. Before you say I'm wicked. If I didn't tell you this now, you would say, now, why is he chasing me away? Now I just came to beg. God, this man is wicked. I'm not wicked. The next time I'll allow them to come and collect small thing from you first. Class, follow me. Determine the central atom. Use bonds to link the central atom to the other. Class, how many other atoms do we have? 4 oxygen and 8 and 2 hydrogens, right? Class, someone that is not experienced will not continue bonding again to hydrogen like this. No. Class, this sulfur can only take 8 electrons. Can only take what? Meaning can only take 4 bonds. Class, never join more than 4 bonds to your central atom. Never join more than what? To your central. Class, where would the hydrogen now go? The hydrogen will bond to the oxy. That's why I told you that the one we did first, H2, is simple. The hydrogen will bond to the what? Class, sir, must it be bonded to these 2 oxygen exactly? No, you can choose any of the 2 oxy. Class, actually, how many electrons have we used up by introducing all these bonds? Each bond takes 2 electrons, right? These 2. How many electrons have we used up? 2 plus 2, 4, 6, 8, 10. 12 electrons have been used. 32 minus 12. Remember that any electron we use there will subtract from total number. Remember that? So only 20 electrons are remaining. Who is stable already among all our elements? Hydrogen is always, once you're giving him 1 bond, it's okay. Sulfur is also stable, right? But he has 8. 4 bonds around him is stable. So this remaining electron will not use to feed those that are not stable. Use to feed those that are not. Look at this oxygen. How many electrons does he have now? 4, right? But 2 plus 2. How many more does he need to be stable? 4 to make 8, right? 1, 2, 3. If you put 4 electrons, where did you collect the 4 electrons from? So subtract it. Any electron you put here, collect from. How many is remaining? 16 electrons are remaining. This guy, how many electrons does he have now? 2 plus 2. How many more does he need to make 8? 1, 2, 3. 16 minus 4. 12. How many electrons does this guy have? How many does he need to make 8? 6. 1, 2, 3, 4, 5. 12 minus 6. 6 electrons left. Who is remaining? How many electrons does he have now? How many does he need to make 8? 6. 1, 2, 3, 4, 5. 6 minus 6.
0.
You have used up all your 32 valence electron, and every element in your level structure is filled up. Every element in your level structure is filled up. Because are you saying that level structure is not difficult?
Yeah.
We have demystified it. That's called demystification. Something that looks difficult but has been demystified. Has been demystified.
5.
This is not normal valence electron. This one is stable octet. Everybody should have 8. You are making everybody have. Do you think that what you are drawing here is what he has here? No, now. He says sulfur has 6. Why are we making it 8? The essence of level structure is to make sure everybody in the element is stable. Sulfur has 6. Do you think he's happy? He wants 8, right? So we are making everybody have 8. And hydrogen has 1. Do you think he's happy? He wants 2. He wants 2. Can we increase the level of difficulty more? Yes. The yes is loud. The yes is
loud.
Interesting. Be careful what you wish for. Now, class. Class. Should I give you a classwork?
Maybe. Small one.
HCN. Draw the level structure of HC. Classwork. If you are following us online, draw the structure of HCN. Draw the structure of HCN. Let's pause the video and let's give you time to solve. But why most of you have not gotten it is because you have not understood some things. Class, first of all, total number of valence electron, right? HC. H is 1, carbon is 4, nitrogen is 5. Did you get this part?
Yeah.
Interesting. 10. Total is 10. Determine the central atom. Class. In this case, all of them are occurring ones. We know it's not hydrogen, right? Between carbon and nitrogen, we know it's carbon. Because carbon is least negative compared to nitrogen. Class, when they all occur the same number of times, you use the electronegativity. The least electronegative element becomes the central. Class, that's why you must go and watch my video on periodic table. So we taught you periodic trends, right? Electronegativity increases what? Across the period and decreases down the... So if you're going from left to right, electronegativity is increasing. And class, if you are going, carbon and nitrogen belong to the same period. Carbon is 2, 4. Nitrogen is 2. So from left to right, electronegativity is increasing, class. In fact, you get to carbon before you get to nitro. So it means that nitrogen is more electronegative than carbon. Please go on, at least even if you miss class, endeavor to be accessing the video. That's why let these videos make sure they are working for you. I will upload all of them again on our paid member. If you have registered for our class fully, there's a registered members group that is different from our general group. I will upload all the videos of the class there, chemistry, all the maths we have done, all the chemistry, all the physics, so you can have them. While you are revising for your exam, one time is giving you a headache, just go and watch at your pace. You can rewind several times. If you are lost, rewind again, watch again. Come again for your own self. Don't say, sir, come again. Come again for your, just rewind, watch again. Rewind, pause, take note of what they say. Okay, I've gotten it now. Okay, this is what he said. Class, carbon comes before nitrogen. I've taught periodic table last week. So carbon is least electronegative compared to nitro, and the central atom must be the least electronegative atom. So carbon is my central atom. So if you didn't get your carbon right, you're already wrong. Now use bonds to join central atom to the other. When you put two bonds, how many electrons are being used? 10 minus 4. So we have 6 electrons remaining. Who is stable now? These other two are not. Class. Stabilize the central atom first. Stabilize the what? How many electrons does the central atom need to be stable? 4. Why did you say 4? But currently he has 4, right? 2 plus 2. 4. So if we had extra 4 to give him 8, right? You started getting it. Well done, class. So 1, 2, 3, 6 minus 4. Remember, any electron you put here, you must subtract it from this place. We have 2 more electrons. Plus, carbon is stable, hydrogen is remaining nitro. Is nitrogen stable? How many electrons does nitrogen have now? He has 2. How many does he need to get 8? 6. How many do we have here? Only 2 is available, and he needs 6. He needs what? Let's collect the 2 first before it disappears. 1, 2. And our number of electrons is finished, but nitrogen is not yet happy. Nitrogen is not yet. Do you not stop here? No. That's where some of you got it wrong. You don't stop. Your level structure is not complete as long as some of your atoms are not still happy. They're not stable. Class, remember that in real life, most elements are not stable. They're not happy because they're not up to the like noble gases, right? And the essence of them bonding is to be stable. Imagine how bonding and you're not still stable. Again, why am I not bonding? So class, you cannot draw a level structure and their atoms are not, that's the reason why they came to bond. That's why nitrogen came here to bond. To share, let us share and give me, let me be stable too. What will happen is this class. These 2 electrons on carbon, how many electrons does nitrogen need to be stable more? Class, this is 2 here already, and it's 2 here, 2 plus 2. With extra 4, it's going to make 8, right? Class, there are 4 electrons on top of carbon. Currently, these 4 electrons on top of carbon is only for carbon. It's going to be required to be shared between carbon and nitrogen. So these 2 electrons will turn to a bond. This other 2 electrons turn to another bond. And they will both share it, and everybody is stable. So this is the Lewis structure of HCl. Check very well, everybody is stable now. Of course, hydrogen just 1 bond makes hydrogen stable, right? Yeah. Now this 1 bond is 2 electrons. This 2 electron, 2 electron, 2 plus 2, 6. Carbon is, now this 2 is 6 plus this 2. Nitrogen is also, are you saying in class? Class, this week, try your best not to miss any of our classes this week. On Saturday is our physics marathon class. Saturday is what? I initially put chemistry, but some people chatted me after, I think it should be physics, since we are starting with. First. Physics and FSB you are starting with. FFB, you read your FSB. Physics we're starting with. FFB does not have calculation, read your FS. Physics is where I'm going to focus on this Saturday. It's going to be exam focused, exam likely questions. If you miss it, class, we thought they want to shift the exam. They will not shift the exam where we are looking so far. They will not shift the. So Monday is physics. So Saturday class is critical. So Saturday, I'll be coming with all my physics powers. Yes, all the powers. On Saturday, so that we can demystify your physics for your exam. So someone give me a wise suggestion, I usually take it. So sir, don't do it with physics, since physics we are starting with first. So that's why I've noticed I put chemistry twice this week to balance my chemistry for the week. We have chemistry today, we have chemistry on Friday. Tomorrow is maths 110, tomorrow is math 1. Wednesday is our shortcut class continuation. You miss Saturday, don't miss Wednesday. How can you miss 2 shortcut days and you want to pass your maths? How? So let's say Saturday is weekend, that's why it will not come. During the week, you also miss. What's now your excuse? And you have the exam next week. Students don't help themselves at all. You miss Saturday, you now miss Wednesday too. So Wednesday is 3 p.m. math shortcut class Wednesday. So I'm giving you a schedule for the week. It's not a normal timetable. Today I'm supposed to have my 2020. We are following the normal timetable. But today I put chemistry because this is exam period. Desperate times require desperate measures. So chemistry today. Tomorrow is math 110. Wednesday is shortcut. Thursday is math 120. On Thursday I'm teaching integration. I've not taught integration yet, right? So and that's the last topic I'm owing you, math 120. Thursday is integration. At least I've done a good justice to differentiation. Integration by partial fraction, by substitution. Friday we'll come back for chemistry, thermodynamics, and kinetic theory of matter. I should round up chemistry on Friday. On Saturday I'll now take physics. Exam focus. Exam. Now class. So that's the plan for this week. Please take note. Today chemistry, we are doing chemistry. Tomorrow math 110 by 10 o'clock. Wednesday shortcut. Thursday math 120. Integration. Friday chemistry again to round up chemistry syllabus. Saturday class, write down resonance. Resonance. Before we do resonance, let's quickly look at ionic. So write down Lewis structure of ionic compounds. Class, what if the compound contains ions? How do we draw the Lewis? If the compound contains an ion, how do we draw the Lewis structure? Class, while we are doing ions, quickly give me the Lewis structure of Ca3OH. I want to be sure that you are very good at it. Ca3O. Give me the Lewis structure of Ca3OH. Give me the Lewis structure of PCl3. PCl3. Give me the Lewis structure of these two. Possible. First step is determine total number of valence. We have 1 carbon, we have 4 hydrogens, and we have 1 oxygen. Carbon brings how many valence electrons? 4. Hydrogen, 4 hydrogens bring 4. Oxygen brings 4 plus 4.
4.
8 plus 6. 14. Who is central atom is clear, right? Who is central atom?
Carbon.
Carbon. Carbon is least negative compared to oxygen. Use bond to join central atom to the other atoms. Class, who are the other atoms? H. Class, because oxygen is different from all this H, first give oxygen one space. First give oxygen one, then fill up hydrogen, hydrogen, hydrogen. But there's one more hydrogen, right? Attach to the oxygen. Did you do this? You know that I told you cannot attach under piece of carbon. Carbon should only have 4. How many electrons have we used up by all these bonds? 1, 2, 3, 4, 5. We've used up 10 electrons. Because each bond represents 2. We have used up 10 electrons. How many electrons are remaining? 4. Who is not yet stable? How many electrons does it need to be stable? Actually, it's 4, right? 1, 2, 3, 4 minus 4. Everybody's happy, right? PCl3, P and 3 chlorine. P gives how many electrons? Phosphorus is 15, right? 2, 8, 5. Chlorine is how many electrons? 7. But we have 3 chlorine. 7 times 3. 21 plus 5, 26. 20 what? Who is clearly the central atom between P and Cl3? Because it's least occurring, right? Now join P to all the Cl. Cl. How many electrons have we used? 2, 2, 2, 6. 26 minus 6. Who is not stable? Nobody is stable yet. But phosphorus is very close, right? This bond gives him 2, 2, 2, 2, 2, 2. How many does it need to be stable? 8. 22 minus 2. 18. How many does this chlorine need? He has 2 now, right? 1, 2, 3, 4, 5. 18 minus 6. This guy also needs 6, right? Also needs 6, right? At the end of the day, all the electrons are used. This is the Lewis structure of what? PCl. Who got PCl3 at least? You got PCl3. Let's teach you how to draw Lewis structure of people that have ions, charges on top of them. When a compound contains a charge, how do we draw the Lewis? Draw the Lewis structure of the following: NH4 plus, ClO4 minus, CO3 2 minus, NO3 minus. Yes, ClO minus. That's chlorine now. ClO4 minus, ClO4 minus, NH4 plus, CO3 2, NO3, charges on top, and how to present them. We played it. Let me do ClO4 minus. Class, total number of valence electrons, Cl and 4 oxygens. Follow me. What is valence electron is chlorine? 7. We all know that, right? Oxygen is 6 times 4, we have 4 oxygens. Now class, ClO4 minus, anytime someone is carrying a minus charge, add 1 electron. If it's carrying minus, add 1. If it's carrying plus, subtract 1. If it's carrying minus, add. If it's carrying plus, so this guy carrying 2 minus, what will you do? Add 2 electrons. This guy carrying plus 1, what will you do? Minus, sharp. So this extra 1 electron, someone should ask me later, so where did it come from? Because I'm doing ClO4 minus. Minus 1 means add 1. And it makes sense. When you are minus, you gained, right? Yeah. That's why we are adding. And when you are plus, you lost. That's why you are subtracting. Total number of electrons will now be 1 plus 7, 8. 8 plus 24, 30. Which central atom between Cl and O4? C. Because O4 is occurring 4 times, chlorine is occurring. So Cl will be in the middle and you extend the rest to what? Oxygen. We have 4 oxygens, right? Use bond to join the central atom to the other 4. Each bond takes how many electrons, class? 2. 2, 2, 2, 2 times 4. 32 minus 8. Chlorine is happy now, right? Each of these oxygen needs 66 electrons to be stable. Because they have 2. 6 to make 8, right? So if you give these 4 oxygens 66 electrons, 6 times 4. So we have 24 electrons to give each of these 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Everybody's happy. Everybody's what?
Happy.
Class, don't show this to EL because I'm teaching. Remember, your final answer in the exam, they say draw left switch of ClO4 minus. All these things will not be shown. Just show this last. Because this is a charge. This guy is carrying a charge. Put a bracket and put the charge is carrying up on top minus. Put a bracket when you are drawing the structure of charges, people that have charge on top of them. After getting the structure correctly, put a bracket and put what? The charge on top. The charge the level structure is carrying, put it on. The charge the level structure is carrying, put it on. Please, if you are in this class and you have not registered after the class, CO3 2 minus. Let me do CO3 2. Let's do CO3 2 minus. Watch. Are you ready? I've played it. Who is central with C and 3 oxygens, right? C is 4. Oxygen is 6 valence electrons, 6 times 3. But 2 minus means what? Add. Never forget. It's very easy to forget. It's under exam tension. It's very easy to forget this guy is carrying a charge and you forget to add it. You will not be having confusion. Why is my electrons not balancing? Why is it not balancing? You've forgotten to add 2 electrons. 4 plus 18, 22 plus 2, 20. Central atom is carbon, right? We are drawing left structure of CO3 2 minus CO3 2. Use bond to join central atom to the other atoms. You can see I'm faster now because I believe that you understand what I'm doing, right? It's always the first one that is slower because it takes time to understand. 2 times 3. I've used 6. 24 minus 6. This carbon is not yet balanced. Put 2 here, right? To give him 8, right? Any electron I put here, I always subtract it here, remember? 16, right? Interesting. Carbon is balanced, but none of my oxygen are balanced yet. This guy needs 6 to be balanced. 1, 2, 3, 4, 5. 16 minus 6. Class, watch, don't underrate this. There's something here, there's resonance here. There's resonance. Follow me, look up, please. Look. This is not your normal one. Don't say I've understood, let me just be writing. I know you can be in that stage, it's the same thing they are doing. No, this is different. Watch. I put 6 here, remaining 10 electrons. I put 6 here, remaining 4. This guy needs 6, but there's only 4 remaining. There's only what? 4 minus 4. No more electron, no more. But this guy is not yet balanced. So class, what will happen there? We come and share these 2. It needs 2 to be balanced, right? These 2 electrons here will now turn to A. And this CO3 2. But class, let me show you resonance that can occur here. Class, what will call mesmeric effects or conjugative effects. But let's leave that. You will learn that very well in second semester chemistry. There are 2 chemistry waiting for you second semester. But let's finish first semester. Now follow me. Anytime there is a double bond between similar atoms like this. Class, there can be movement of this double bond. This second bond is called a pi bond. We have 2 types of bond in chemistry. We have a sigma bond and a pi bonds. We have the sigma bond and the pi. Class, the first bond in every bond is called a sigma, and the second bond is called a pi. Class, the pi bonds easily move. Class, this pi bond, this one on top, can easily move because you would ask yourself, and this the oxygen now, must I always be here? If it sees a similar atom to where it was before, it can move and come here. And the second what? Resonance structure is formed. So when it moves and comes to this cycle, what will happen? The double bond is down here.
and this one is filled with the number electron, normal.
And the third one, class, this guy can produce 3 resonance structure, class. If they ask you to draw the Lewis structure of a compound that can produce resonance structure, class, if you draw only one structure, you are wrong. If they say draw the resonance structure of this compound, you must draw if you ask 3 resonance structures, you must draw 3 structures. But they will not tell you 3. They will just say draw the Lewis structure. If a compound exhibits resonance, class, you are not to draw one structure, you have to draw all the resonance. How do you know how many resonance structure a compound will exhibit? Class, resonance exists in compounds that contain similar atoms occurring multiple times, and there is a multiple bond. Class, if you don't have double bond in your structure, you cannot exhibit resonance. For resonance to occur, there must be a double bond or a triple bond in that compound. And there must be similar atoms occurring more than once. Look at the third resonance structure. Class, first of all, the pi bond moves to this side, right? It can then move to this. What I'm trying to say is that, looking at this compound, only one oxygen have double bond. What is to say that this double bond should not be in this oxygen? Or should not also be in this? So because of they are the same atoms, why do we put it here? So in order to ensure impartiality, there will be 3 structures. One of the structures, the double bond is on the first oxygen. Second structure, double bond is second. The third structure, double bond is on the third oxygen. And then 3 resonance, 3 what? Three resonance, all carrying their 2 minus. So if they were to ask you to draw the Lewis structure of this kind of compound, do not put one structure, you will not get your full mark. You must show all the 3 resonance, except the compound does not exhibit resonance. Class, someone like HCl we did before, can he exhibit resonance? No. Because there are 3 different atoms. Resonance usually occurs when you sense that there can be resonance. If there's one atom and then there's another atom that's occurring like 2-3 times there. And then there's a double bond or a triple bond somewhere. Class, what I'm saying is that double bond can shift to the other atom since they are the same. The number of times it can shift determines the number of resonance structure that can be formed. This is the first resonance structure. It shifted here, another resonance. Shifted here, another resonance. Because of the why must it be on this oxygen only? Double bond. Why this oxygen is not different from this oxygen? It's not different from this. Are we together, class?
The resonance structure cannot be more than 3.
Huh?
It cannot be more than 3 now.
It can be more than 3. It depends on the structure. But for your set, maybe 3 should be the highest. Now, class, look at SO2. S what? S is 6. O2 oxygen is 12. 6 plus 12. 2 electrons, they are giving you 4 electrons have been used, right? How many is remaining? 14. How many electrons does this guy need to be stable? 4 more. 1, 2, 3. 14 minus 4. 10. This guy needs 6. 1, 2, 3, 4, 5. 10 minus 6. This guy needs 6, but there's only 4 available. 1, 2, 3. 4 minus 4. 0. This guy is not stable. You will collect one of these 2 electrons and share with her. And do what? For class, there's no bond here, right? But there's a similar atom here, right? This double bond can shift to this, so that a second resonance structure is formed. Anytime there's a double bond, and the atom here is same as the atom here. Why must it be on this oxygen? Oxygen is oxygen, right? So why must it be? This pi bond can easily move to this, and the second resonance structure is formed like this. So this one is not the one having double bond this time around, right? This is the person having the double, and the person having the double bond will have just 4 electrons, so there can still be 8 Watch, anytime you double bond shift to this side, these guys are now assist, all the electrons will now be here. And this one that 4 will now have 4 electrons. You know what I mean? So that the total number of electrons is still 8. 1, 2, 3, 4, 5, 6, 7, 8. And this 1, 2, 3, 4, 5, 6, 7. Class, I believe that when you get home, you can easily draw the relationship of these ones. Now, moving forward, I've just explained resonance. Another name for resonance is canonical forms. If they say draw all the canonical forms of the compound, they're simply asking you to draw the resonance structure. Canonical. Write down formal charge, formal charge. Why are you asking me that? Now, can't you draw Lewis structure? What kind of question is that you asking? Class, formal charge. The formal charge of any atom in a Lewis structure. The formal charge of any atom in a Lewis structure is the charge the atom will have. The formal charge, formal, F-O-R-M-A-L. 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 F-O-R-M-A, formal. The formal charge of any atom in a Lewis structure is the charge the atom will have. Is the charge the atom will have if all the atoms in a molecule have the same electronegativity. If all the atoms in a molecule have the same electronegativity. Formal charge of any atom in a Lewis structure is the charge the atom will have if all the atoms in the molecule are the same electronegativity. Is the charge the atom will have if all the atoms in the molecule are the same what? The formula for formal charge, we call it Fc. Formula for formal charge is valence electron minus number of dot electrons minus number of bonds attached. Minus number of bonds attached. Formal charge is valence electron minus number of dot electrons minus number of bonds attached. Let's look at the Lewis structure of SO3 minus, 2 minus, sorry. SO3 2, who is total number of valence electrons? Plus 2 plus 2 minus add 2, right? Put S in the center, right? Use bonds to join S to the other oxygens. We have used 8 electrons, 26 minus 8. 18. Minus 8 is what? 18, right? 2. 6 times 3. Class, this is the Lewis structure of SO3 2 minus. Class, imagine you are asked to find the formal charge of sulfur. Determine the formal charge of sulfur in SO3 2 minus. Calculate the formal charge of a particular element in the Lewis structure. Formal charge is the number of valence electron. So we're looking for the formal charge of sulfur. Sulfur, what's the number of valence electron of sulfur? 6 minus number of, how many dot electrons are around sulfur? 2 minus number of dot electrons, 2 minus number of bonds attached. How many bonds are attached to sulfur? 3. 6 minus 2 minus 3 minus 2 minus 3 minus 5. 6 minus 5, 1. So class, the formal charge of sulfur in SO3 2 minus is 1. The formal charge of sulfur in SO3 2 minus is, what's the formula for formal charge again, class? The number of valence minus number of dots minus number of bonds attached. So to get formal charge, you must be able to draw Lewis structure first, right? That's why I taught Lewis structure before formal charge. That's why I taught what? You have to draw the Lewis structure, then find the formal charge of sulfur. Number of valence electrons of sulfur is 6. Sulfur is number of dots. How many dot electrons are around sulfur? Just 2. Minus 2. How many bonds are attached to sulfur? 1, 2. So if your Lewis structure is wrong, you have a wrong formal charge, right? Because if you have wrong number of bonds or you have wrong number of dots, you have a wrong formal. Can someone help us find formal charge of oxygen? Class, since all the oxygens have the same characteristics, right? Oxygen has 6 dots and 1 bond. 6 dots, 1 bond. 6 dots, 1. So any oxygen you find, you have gotten a formal charge of that oxy. Number of valence electrons 6 minus number of dot electrons 6 minus number of bonds 6 minus 6 minus 6 minus 6 is 0. 0 minus 1 is minus. So the formal charge of this oxygen is minus 1. Also minus. Also minus. And sulfur is what? 1. Sulfur is what? What gave me the right to say that all the oxygen are minus 1, minus 1? They have the same characteristics. 1 oxygen, 6 dots, and 1. So even if I find it, I'll still have minus 1. Even if I find it, I'll still have minus. Class, this is now what we call the net formal charge. Net what? The net formal charge is a summation of the formal charge of each atom present in a Lewis structures. The net, right? A net formal charge is the summation, or you can say the addition, anyone. Net formal charge is the addition of the formal charge of each what atom present in a Lewis structure. The net formal charge is the additions of the formal charge of each atom present in a Lewis structure. The net formal charge is the addition of the formal charge of each atom present in the Lewis structure. Class, if I was too fast at any point, there's some parts you didn't understand, I was too fast. There's a video, remember, you can go and watch it. The net formal charge is the addition of the formal charge of each atom present in the Lewis. So the net formal charge will be formal charge of this oxygen minus 1 plus minus 1 plus 1 plus is the addition of formal charge of each atom in the Lewis. So this is minus 1 for this, minus 1 plus minus 1 minus 2. Minus 2 minus 1 minus 3. Minus 3 plus 1 minus 2. Minus. Class, to know that you are correct, your net formal charge should tally with the total charge of the element, of the compound. What is the charge of this Lewis structure? And our net formal charge also minus. Showing correlation, showing what the correlate between your calculation and the actual value. What's net formal charge again? Net formal charge is the addition of the formal charge of each atom in the Lewis structure. You know the formula to find formal charge of each atom in the Lewis structure, right? Formula is still on the board. Valence electron minus number of dot electron minus number of bonds attached. So you go to the formal charge of this guy, this guy, this guy, this guy. Now say find the net. The net is addition of all the formal charge of each atom. Minus 1 here, minus 1 here, minus 1 here, plus 1. Minus 1 minus 1, minus 2 minus 1, minus 2 minus 1, minus 3 plus 1, minus 2. the net formal charge of SO3 2 minus. So let me just tell you, if they ask you to find the net formal charge of a compound, look at the charge the compound is carrying. That's the net formal. Don't solve. Don't find the net formal charge of NH4 plus. Plus, what is the answer? Net formal charge of NH4 plus. But even if you do this calculation, you still get the same. Where you will need to solve, if they say find the formal charge of nitrogen in NH4 plus. Find formal charge of what? If they pinpoint one element in the level structure, you need to go and solve, right? But find the net formal charge of everything is that compound. Claire, what is the net formal charge of an uncharged element like CO2? 0. Thank you. The net formal charge of an element that is not carrying a charge is what? 0. Write down bond order. Bond. You see in your question passage somewhere they say calculate the bond order, determine the bond order for this. Bond order. The term bond order refers to the number of bonds that exist between two atoms. Bond order refers to the number of bonds that exist between two atoms. Bond order refers to the number of bonds that exist between two atoms. Bond order refers to the number of bonds that exist between the two atoms. Note, the bond order of a diatomic molecule is defined. Note, the bond order of a diatomic molecule is defined. Note, the bond order of a diatomic molecule is defined as the 1/2 the difference. As the 1/2 the difference between the number of electrons in the bonding orbital, as the 1/2 the difference between the number of electrons in the bonding orbital and the number of electrons in the anti-bonding orbital, and the number of electrons in the
Between the number of electrons.
bonding orbitals. I said the bond order of a diatomic molecule is defined. The bond order of a diatomic molecule is defined as 1/2 the difference. 1/2 the difference. 1/2 the difference between the number of electrons in the bonding orbital, between the number of electrons in the bonding orbital and the number of electrons in the anti-bonding orbital. So generally, bond order, formula for bond order is bonding electrons, bonding what? Minus anti-bonding electrons. Anti what? Divided by 2. Divided by what? That's 1/2.
I have a question in the last topic.
No, after the class. Note, bonding electrons are electrons on the bonding molecular orbital. Bonding electrons are electrons on the bonding molecular what? Orbital.
On the
Pause it, let me fix. Contains bonding molecular orbital and anti-bonding molecular orbital. Molecular orbitals contain bonding molecular orbitals and anti-bonding molecular orbitals. Molecular orbitals contain bonding molecular orbitals and anti-bonding molecular orbitals. The bonding molecular orbital have a lower energy compared to anti-bonding molecular orbitals. Bonding molecular orbital has a what? Lower energy compared to anti-bonding molecular. Bonding molecular orbitals have a lower energy compared to what? Anti-bonding molecular orbitals. When feeding electrons into the orbitals, when feeding electrons into the molecular orbitals, the following order must be observed. The following order must be what? Observed. When feeding electrons into molecular orbitals, the following order must be what? Observed. For lighter molecules, this is the order. Why for heavier molecules? For heavier, what are examples of heavier molecules? O2, F2, Na2 and its ion. What are examples of lighter molecules? He2, Li2, Va2, B2, C2, and its ions. And what? And ions. And its ions. So for lighter molecules, we follow this order. Sigma 1s, then sigma asterisk 1s, sigma 2s, then sigma asterisk 2s. I'll teach you what they mean, don't worry. Pi 2py, pi 2pz, sigma 2px, pi asterisk 2py, pi asterisk 2pz, sigma asterisk 2px. And for heavier molecules, we have sigma 1s, sigma asterisk 1s, sigma 2s, sigma asterisk 2s, sigma 2px, pi 2py, pi 2pz, pi asterisk 2py, pi asterisk 2pz, sigma asterisk 2px. Class, I said we have two types of molecular orbital, bonding and what? Anti-bonding. Class, anytime you see asterisk on an orbital, just know there's anti-bonding and anytime you don't see asterisk, it's bonding, is what? Now class, when feeding electrons in orbital, real molecular orbitals, we start from the lower energy level before the higher energy level. Class, notice that the bonding orbitals, I told you, let's check the note, I said bonding orbitals have a lower energy compared to the anti-bonding. Bonding orbitals have a lower energy level compared to the anti-bonding orbitals. Bonding orbitals have a lower energy level compared to the anti-bonding orbitals. So class, you notice that before every, you see sigma 1s before sigma asterisk 1s. This sigma 1s is for the bonding orbital. Sigma asterisk is for the anti-bonding. Sigma 2s, bonding. Sigma asterisk anti. The bonding always comes before the Class, when filling electrons in molecular orbitals, under molecular orbital theory, we follow this sequence. I'll give you an example soon. Class, this sequence is for lighter molecules. So you're using this sequence when you're doing lighter molecules, and you're using this sequence when you're using heavier. What's the major difference between this sequence and this sequence for lighter and heavier molecules, right?
Right.
Class, follow me. In the lighter molecule, notice that pi 2py and pi 2pz came before sigma 2px. Pi 2py and pi 2pz came before sigma 2p. Class, actually, this topic, when you start doing it well, it's in 200 level. But there's something I need to teach that makes me bring out these things. Is that part when they ask you for bond order. Notice in our past question, when they ask for bond order, I just saw that not explain. Why? Because it's not something that you understand even if I solved it in a past lesson. So once in a while, you just bring it in exam, find the bond order. And to learn the bond order, you must know all these things to understand the bond order. But it's not, so don't be too disturbed. It's not everything that will come out like this, you understand the exam. It's just to teach you bond order, that's why I'm doing all this. Plus, watch in the lighter molecules. And this molecular orbital theory is going that specific into the orbitals. Plus, remember that when we were doing electronic configuration SPDF, I just told you 1s, 2s, right? 2p, 3s, 3p. But this one is going into the, what is this happening in the p orbital? This 2p split into 2px, 2p. The splitting is more specific. Are you seeing it? It's more. So as I go in higher, they will be opening the chemistry for you more. That's how book is. When you're in GS1, there's where they open it for you small. You enter SS1, they open it again. SS1, university, they open it. Masters, they say, no, so knowledge is keeps. Nobody knows all, knowledge keeps going. So class. So if you are actually writing electronic configuration based on molecular orbital theory, you are not allowed to say 1s2. If they say write down the molecular orbital configuration, class. If they say write down the electronic configuration, SPDF configuration, you say 1s2, 2s2, 2p6. But if they say write down the molecular orbital configuration, you must follow this pattern. That means considering the bonding orbital and the anti-bonding. In this pattern, there are two types of orbital, the bonding orbital and the anti-bonding. The bonding orbital are the ones that do not have asterisk. Why the anti-bonding orbital has? The bonding orbital usually comes before each anti-bonding orbital because the bonding orbital has lower energy than the anti-bonding orbital. The bonding orbital has a lower energy than the anti-bonding. And class, for lighter molecules, we have a sequence. For heavier molecules, we have a. So if someone says write down the molecular orbital configuration for lithium Li2, you're using this sequence. But if someone say neon 2, you're using another sequence. Notes. In the lighter molecule, pi 2py and pi 2pz is of lower energy than sigma 2px. Is of lower energy than what? Sigma 2p. As a note, in the lighter molecule, pi 2py and pi 2pz is of lower energy than what? Sigma 2px. Is of lower energy. But in the heavier molecule, check. Class, in the heavier molecule, check. Sigma 2ps come before pi 2py and pi 2p. Are you seeing it? That's just the major difference between lighter and heavier molecule. That's the major difference. Note, each molecular orbital can contain a maximum of 2 electrons only. Each molecular orbital can contain a maximum of what?
Class, you're not allowed to fill more than 2 electrons in each molecular orbital. Because class, don't forget that PS is just 1 block. And 1 block can take 2. PY is also 1. PZ is 1. And of course we know electron must enter the lowest energy level first before the highest energy level. Class, another thing you should note. Look at this if I underlined. Look at these 2 I underlined. When filling electrons in them, these 2 are degenerate orbitals. They are degenerate. What are degenerate orbitals? Degenerate orbitals are orbitals of equal energy levels. Equal what? Degenerate orbitals are orbitals of equal energy. And what they also tell us about degenerate orbitals? That we should fill singly before pairing. What do I mean? Because very soon I will give you a question. I'll say write the molecular orbital configuration of so and so. We have to fill singly before pairings. So if you have 2 electrons to fill here, you won't just put 2, you put 1 here, you put 1. Example, right? Let's apply. If you don't apply, this thing will look so confusing to you. If you don't apply, it will look so confusing to. Who are the degenerate orbitals? You could be asked in the exam, it's subjective exam. Orbitals of equal energy level are referred to as dash degenerate. Write down the molecular orbital configuration for the following species: He2, He2. Write down the molecular orbital configuration for the following species: He2, He2 plus 2, Be2 plus, Li minus 2, write down the what? Molecular orbital configuration of the following species: He2, He2 2 plus, Be2 plus, and Li2 minus. Write down steps involved in writing electronic and molecular configuration. Steps involved in writing molecular orbital configuration. Steps involved in writing molecular orbital configuration. Steps involved. Steps involved in writing molecular orbital configuration. Steps involved in writing what? Molecular orbital configuration. Steps involved in writing what? Molecular orbital. 1. Determine total number of electrons present in the diatomic molecule or ion. Determine total number of electrons present in the diatomic molecule or ion. Determine total number of electrons present in the diatomic molecule or what? Ion. Determine total number of electrons present in the diatomic molecule or ion. How do you get total number of electrons? Write down total electrons, Te, total electrons, Te, total what? Equal to sum of the atomic number of the 2 atoms. Equals to sum of the atomic number of the 2 minus the charge. Minus the charge. Total electron equals to sum of the atomic number of the 2 atoms minus the charge. Sum of the atomic number of the 2 atoms minus the what? Sum of the atomic number of the two atoms minus the charge. Sum of the atomic number of the two atoms minus the what? Charge. That's how you calculate total You say steps involved in writing molecular orbital configuration. Now, step 2 now. After determining total number of electrons, right? 2, start placing electrons in each orbital. Start placing electrons in each orbital. Note, maximum of 2 electrons are allowed for each orbital. Note, maximum of 2 electrons are allowed for each orbital. Note, maximum of 2 electrons are allowed for each orbital. And for molecular orbital, you fill singly before pairing. And for degenerate orbitals, you fill singly before. Let me come again. Start placing an electron in each orbital. Start placing an electron in each orbital. Note, maximum of 2 electrons are allowed for each orbital. Maximum of 2 electrons are allowed for each orbital. And when you get to degenerate orbitals, you fill singly before. When you get to degenerate orbitals, you fill what? Before pairing. Fill singly before pairing. Class, you keep being lost until we take our first example. He2. You want to write the molecular orbital configuration for He2. Is He2 a lighter molecule or a heavier molecule? So you are following this sequence. Total number of electrons for He2 is, what is the atomic number of He2? 2. But we have 2 atoms of He2, that will be 2 times, giving you what? Minus number of charge. Is there any charge on He2? So charge is 0. Charge is 2 times 2, 4 minus 0. So total number of electrons for He2 is 4. He2 is what? Now let us write the molecular orbital configuration for He2 to start on the lowest energy level. Sigma 1s 2 and sigma asterisk 1s 2. 2 plus 2. Class, you stop here because you have only 4 electrons. You have only what? So this is the molecular orbital configuration for helium. This is the molecular orbital configuration for what? Helium. What if it was carbon C2, class? What if it was carbon C? Class, what's the first step? Determine total number of electrons. First, what's the atomic number of carbon? 6, right? Your atomic number tells me the number of electrons you have. The number of proton equals number of electrons, since you are on charge. 6 times 2. 6 times 2. 12. Minus charge. Total number of electrons is number of minus charge, right? I give you the formula of total number of electrons, right? What the charge on carbon is on charge? 0. So 12 minus 0. 12. Total number of electrons for carbon is 12. Let's now write the molecular orbital configuration for carbon. Let us write the molecular orbital configuration for. Start from the. Is a lighter molecule, right? We're going to write sigma 1s 2, sigma asterisk 1s 2. We are going to 2f, remember? Sigma 2s 2, sigma asterisk 2s 2. 2 plus 2. 8. Now when coming here, you fill singly before pairing. So pi 2p y1, pi 2p z1. 2 plus 2, 6, 8, 9, 10. We are going to 12, right? So there's space to increase this one now to. This is the molecular orbital configuration for carbon. Class, can I now relate this to bond order? Bond order says that number of bonding electrons, bonding what? Minus number of anti-bonding divided by 2. Class, who are the bonding electrons? Are the electrons on the bonding orbital? Who are the bonding orbital? The orbital that don't have asterisk. Orbitals that don't have. Who are the orbitals that don't have asterisk? So how many bonding electrons do we have? 2 plus 2. 4 plus 2. 6 plus 2. 8 bonding electrons. Who are bonding electrons? They are the number of electrons on the bonding orbital. Who are the antibonding electrons? Electrons on the antibonding. Who are antibonding orbitals? The one that have asterisk, right? How many antibonding electrons do we have? 2, 4. This is antibonding, right? 2. So 4 antibonding So 8 bonding electrons minus 4 antibonding divided by, we give me the bond order for carbon. So in the exam, they say calculate the bond order for carbon. This is what you should do. Could I have taught bond order without teaching all these things? No, you won't understand. 8 minus 4. 4 divided by 2. Bond order of carbon 2 is 2. Bond order for C2 is what? 2 class. You see how molecular orbital theory relates to bond order now, class? You don't get anything less than A in this course. So the way I teach my courses, if you are bringing B, I used to be angry. Because I give it my best, so you to give it your best. If I wanted you to get C, we should be done with the class by now. If you see, you look for, you can carry your bag, we are done. C students, you can start. You are done. I don't overteach self. Sorry for the pigeon, but I've overtaught. Do you understand? So if it's C you want, but this kind of standard of teaching, going deep into chemistry, like this year 2, year 3, can go ask year 3 students. That's what they're learning now. Chem 261 or so, 360 something. But without breaking this down, you cannot get bond order. Class. So imagine also to write the bond order for O2. O2 means, O2 is what? 8. Atomic number of oxygen is 8 times 2, 16. 16 minus 0. Because it's on charge, so there's no charge, minus 0, 0. I'll soon do the one that has charge so you understand, eh? So we are going to 16 electrons. Oxygen is a lighter or heavier molecule? So we are following this chart. We're following this sigma 1s 2. We want to fill 16 electrons, right? Sigma asterisk 1s, sigma 2s, sigma asterisk 2s, sigma 2px 2, pi 2py and pi 2pz. Have we got 2 plus 2? 6, 8, 10. How many can stay? 2, 2. 12, 14. Pi asterisk 2py 2 and pi asterisk 2pz. This is the molecular orbital configuration for oxygen. This is the molecular orbital configuration for oxygen. Let's take one that has charge on top. Let's do He2 2 plus. That's helium ion. He2 2 plus. He2 2. He2 is a lighter molecule, right? This everybody here and their ions are lighter. He2 2 plus is a lighter molecule. We want to do the He2 2. Class, total number of electrons is 2 times 2. Minus charge, what's the charge? 4 minus 2. So total number of electrons we're writing for He2 2 plus is 2. Just 2 electrons. And 2 electrons can fill only this side. Sigma 1s. Class, this is the electronic configuration for He2 2 plus. He2 2. So back to your exam question. If then ask you to find the bond order for He2 2 plus and find the bond order for just He2, you know your answer will be different. Find the bond order for He2 2 plus and He2, the answer will be, what's the bond order for He2 2 plus? Number of bonding electron minus antibonding divided by, what's the bonding electron here? 2. Is there any antibonding electron here? So 0 divided by 2 minus 0. 2. 2 minus 0 said 1. 2 minus 0. 2 divided by 2. So the bond order for helium ion is 1. But let us check the bond order for normal helium without the charge. Uncharged helium. Have we done the bond orbital theory for He2 before? It's sigma 1s 2 and sigma asterisk 1s. Because He2 means 2 times 2, 4, but there's no charge. 4 minus 0 is 4, right? So what's the bond order for He2? Number of bonding electron. Number of antibonding electron. All over 2 minus 2 over 2. What is 2 minus 2? 0 divided by 2. So bond order for He2 is 0. The bond order for He2 is what? 0. Class, to be sure that you know it, give me the bond order for lithium 2 minus. See? There's a video now. That's what I'm saying. There's a video. Go and watch it. Lithium 2 minus. Some of you need to go and sit down when you are less tired to watch it. It's normal that at the end of the class, your energy level will be reduced. And you might not, your concentration level will also drop. When you've gotten home in the evening, you are freshened up. Go to our videos and watch. Study. Take your time and look at it again, right? You can rewind. Oh, what did you say there? Rewind, watch several till you get it. Give me the bond order for lithium Li2 minus last one for today. Is lithium a lighter or a heavier molecule? Check your book. Is it lighter or heavier? It's lighter, right? So give me the bond order for Li2 minus. It's lighter. Class, the class will go ahead. Hydrogen, helium, lithium. Lithium is number 3, right? But we have 2 lithiums here. 3 times 2, 6. 6 minus, what's the charge? Minus 1. Subtract the charge from it. Subtract the charge from it. 6 minus minus. Always subtract the charge if it's having a charge, right? What is minus times minus? 6 plus 1. Total number of electrons for lithium Li2 minus 1 is 7. Is what? So you are filling for 7 electrons. Sigma 1s2. As you are practicing this thing, don't pick any day to cram this thing. So just practice several questions to stick to your head naturally. There are some things that you never crammed one day. You were solving with them until something like just got into you. This is the best way to learn. You cannot sit down and say, let me cram it. Alpha 1s, alpha 2. I want to take your mad. What are you talking about? Sigma 1s, sigma pi 1. What did they do now? How can we see that one? Just be practicing several. Just take it. So one day you just say, I'm not taking this thing again. How? You just stick to your memory. Sigma 1s2, sigma asterisk 1s. We are going to 7, don't forget. Sigma 2s, 2. Sigma asterisk 2s. So bond order is number of bonding electrons. Who are the number of bonding electrons? 2 plus 2. Minus number of antibonding. How many antibonding electrons do we have?
3.
Divided by 4 minus 3.
1 over 2.
So the bond order of lithium 2 minus 1 is 1 all over 2 or 0. Class, at this junction, I'm done with Lewis structure, bond order, bond polarity, resonance structure, formal charge. Thank you very much. Thank you. You can clap. You can clap. It's not easy. It's not. You can first stop the video now. Stop the video.